On this example, you're again going to be drawing a scatter plot, finding the least square line and correlation coefficient. The one tricky part here is that you'll see it says let x be the number of years since 2001. This is something that you will see on your homework, and I can almost guarantee it's going to throw a couple of you off for a little while. But just remember that when you're putting in your x value, it's not your year. It's not even always going to just be whatever the year ends with. In this case, we're talking about the number of years since 2001. So in the year 2001, say year, the x value that we would be using there would be 0, because in the year 2001, it's 0 years since 2001. In the year 2002, well, that's 1 year since 2001. And if I was to continue this on, 2003, you'll notice that's going to be 2 years since 2001. The quick way to get this, if you're looking at, let's say, 2007, we're jumping over there, 2007, well, you'll notice that you can get these values, the 0, 1, 2, by subtracting 2001 from it. If you're talking about the number of years since 2001, you can just do subtraction. So 2007, well, subtract 2001 from that. This is 6 years since 2001. So that's something to keep in mind when you're when you have one of these questions where it's correcting a certain number of years since 2001. All right, so let me go ahead and enter that into the calculator. I'm going to go edit. I'm going to go up to L1 and clear, enter, clear, enter. Okay. Just clearing out my old stuff. Let's see. This data actually started out, this was a y value of 2, 3, 4, 5, and 6. I'm actually writing it on there so I don't make a mistake halfway through. So we say 2, 3, 4, 5, 6. And oops, I did make a mistake there. Let me fix that. I'm going to be pressing delete on each of these to get rid of them. I don't want to clear the whole list. I'm going to go over to L2 and re-enter them over here. Alright, there we go. I've re-entered them. They're now in L2. You'll notice L1 and L2 are the same length. The calculator would give us an error. It would probably say dimension mismatch, or dim mismatch, I think is what it's called, if you had more x coordinates than y coordinates, because it wouldn't know how to make a point out of it with just an x coordinate without a y coordinate. Alright, so I've entered in all of those points. I want to find the least square line. I guess I should probably draw a scatter plot too. I'll get to that in just a second. I'm going to go stat, over to calc, then reg, hit enter, and just like that it gives me my slope, my y-intercept, and my correlation coefficient. Alright, so I just wrote down what those are. You can see A, again, was my slope, so it becomes 88.73 times x. B was my y-intercept, so that becomes my y-intercept, and I'm using r, not r squared when we're talking about the correlation coefficient. So the last thing I want to do here is draw a scatter plot. Let's see, x and y. Again, I want to be careful to make sure that I show all of the values that are relevant. In my x's, that's fairly easy. I can just go up to 6. Let's go 2, 4, 6. With my y's, though, you'll notice if I start out at 0 down here, and I say, 2600, then all of these are going to be, they're all really close. It's going to look like a horizontal line, because this is, well, I guess 2200 would probably be right here. 2600, it would look fairly horizontal like that. Sometimes a common trick that's done to kind of zoom in on the data is to, instead of saying it goes down to 0 here, they do a break in the graph. Let me see if I can draw a little cleaner version of that. Draw a little break in the graph. Oftentimes it's done with a symbol that looks like that. This is to show that there's a discontinuity. Anything that goes, if you have a line that's going past that discontinuity, it might jump over here, because you're basically saying you're going to be cutting part of the graph out. And what you can then do is say, okay, I have 2600 up here, I have 2200 down here, and this allows you to kind of zoom in a little bit more on the points that you care about. So let's see, we have 2250. Actually, let me get a little bit more accurate here. This is 2200, this is 23, 24, 25. All right, so 2250 would be about there. Here we have 2319, which is going to be up here. Oops. And I'll be back when I finish plotting those. All right, so I plotted the remaining points there, and you can see this looks like it is pretty linear. That's kind of what the line looks like there. Now, again, if you were to draw a line in here, you wouldn't want it to continue past your discontinuity here. You wouldn't want to say the slope looks like it should be about there, because, well, that's going over that discontinuity. Actually, you know, if you were to draw this, 2600, 2200, it should actually hit way up here. You can see it actually crosses at 2064. If I was to draw this over the discontinuity, it looks like I have a negative y-intercept, and clearly that's not accurate because my y-intercept should be about 2064. So this is something, frankly, you should kind of be on the watch for. You know, it's political season right now, and oftentimes people will show graphs that may be a little misleading. And one of the things that I commonly see with graphs that is misleading is they'll do something like this, and they won't indicate that there's a discontinuity. They'll do something like, you know, here's the competition, and here's us. When in reality they're talking about maybe 38.4 and then 39.1. You know, they just rescaled the graph to make it look like theirs is moderately better, but not anywhere near to the extent that they made it look. Instead, if they actually had a, you know, kind of a more, I don't know, true and a more accurate graph, less misleading, we should say, if they actually had it going all the way down to 0 here, and then really they would say, okay, here's our competition and here's us. You know, 38.4 is there and 39.1 is there, and you know, it's almost an imperceptible difference. But if they rescale the graph, they can make it look much bigger. So like I said, this is just something to watch out for. And frankly, when I see somebody post something like this, or when I see a graph that looks like that, I always, from then on, I look at that point, that whoever posted that, with a lot more skepticism, because clearly they're willing to manipulate the data in a not very honest fashion, in my opinion.